Alright, today or right now we're going to talk about finding x and y intercepts. What is a x or y intercept? It's simply a point on the x or y axis. That's all. It's really a point on the x or y axis. A little quick demonstration just to show you what we're working with. Y-axis, x-axis. Alright, now hopefully this works. On the y-axis, if I have a point anywhere on the y-axis, the x number will be 0 and the y number will be some number, up, down, or whatever, positive or negative. On the x-axis, the x number, the x coordinate would be some number and the y coordinate would be 0. Anytime a point is on the x-axis, the y has to be 0. Anytime a point is on the y-axis, the x has to be 0. We should know that one already. We've spoken about that at length. That's B in slope-intercept form. However, today we're going to focus on simply trying to find those two. Alright, so notice that they're points. Keep that in mind. Now this is good to know. And that's just what I just got through saying. Now, how do we actually find them? Now, I always say it don't matter which one you find first because some people think you got to find them in a certain order. It doesn't matter, and it's really simple. However you find them. You substitute 0 in for the x and solve for y. That's for your y-intercept. You substitute 0 in for y and solve for x. That's for your x-intercept. And you should get two answers. Never combine them into one. Every intercept has a 0 in it. So if it doesn't have a 0, it's not an intercept. So you can't combine two different numbers into one super point and say this is your answer. No. And don't let the equation throw you off. So let me stop talking and got all that down, I assume. So let's jump into this. Now, what you might want to try to do is kind of stop me before I start and see if you can figure these out. So like pause and then try to see if you get the answer, if you haven't already been doing that. Whenever I do the x and y intercepts, I like to make this little table. It just keeps stuff organized. Now, you don't have to do this. This is not necessary, but it's kind of helpful. The x-intercept is where y equals 0. I'm start on the x-intercept side. So I'm going to take this equation and I'm going to rewrite it. And whenever I get to y, I'm going to make it 0. 3x minus 4 times 0. When I say make it, I substitute 0 in for y. That's what the note said. So I substitute 0 in for y. Now this right here just becomes 0, right? Negative 4 times 0. So I have 3x equals 12. Divide both sides by 3 and I get x equals 4. Okay? Now you can leave it like that, or as a point it's 4 comma 0. How do you remember? X equals 4, y equals 0. There you go, right there. Y-intercept is where x equals 0. So I'm going to rewrite that same equation. And whenever I get to an x this time, I put 0. So 3 times 0 is 0. And I'm left with negative 4y equals 12. To continue to solve for y, I get y equals negative 3. As a point, x is 0, y is negative 3. It's 0, negative 3. So that's how you would answer. Notice I have two separate answers. Notice I didn't take 4 comma negative 3 and make that into a point. You don't do that. An intercept has to have 0 in it, and that's what's really important. Never make them into one super conglomerate point. Alright, number 2. I'm going to find the x-intercept and the y-intercept. And again, this little chart table looking thing is not something that's necessary, but I like doing it because it just keeps my thoughts and stuff in order. The x-intercept again is where y equals 0. So again, this is a different looking equation. And this says it doesn't matter what your equation looks like because I'm still going to follow the same procedure. I'm going to rewrite this equation, and whenever I get to y, I'm going to put 0 in its place. 2 times 0 is 0. So I have 0 equals 5x minus 3. Now I can solve for x. So I add 3 to both sides. What is this? This is a two-step algebra 1 equation. Divide both sides by 5, and look there, I get a fraction. There's no rule that says your answers are always going to be this nice, pretty whole number. You'll get fractions from time to time. And again, as a point, that's going to be 3 over 5, 0. Now, your y-intercept is where x equals 0. So again, I go over here, and whenever I get to the x, I'm going to substitute 0 in its place. And notice when I substitute, I always use parentheses because it lets me know I'm substituting, and that's multiply. It's not 50. All right, 2y equals negative 3 because 5 times 0 is 0. 0 minus 3 is negative 3. Divide both sides by 2, and you get y equals negative 3 over 2, or you can change that to negative 1 1/2. And as a point, that's 0, comma, negative 3 over 2, or negative 1 1/2. Again, that's an answer, and that's an answer. All right, moving on to number 3. What you'll notice about number 3 is it don't have 3 terms or items. 1, 2, 3 in number 2. 1, 2, 3 in number 1. We have 2 in number 3. See if you can come up with something based on that after I work it. X-intercept and the y-intercept. The x-intercept is where y equals 0. And so I put or substitute 0 in for y. I get 0 equals 3x after I multiply. Divide both sides by 3. And I get x equals 0. And as a point, it's going to be 0, comma 0. Over here, the y-intercept is where x equals 0. That will be 7y equals 3 times 0. So 7y equals 0 again. And you divide both sides by 7 and you get y equals 0. And as a point, that's 0, 0. So what do you notice? That the x-intercept and the y-intercept are exactly the same. That's the only time it happens, whenever you don't have a b or another number out here. If you don't have a constant, a number with no variable, you're always going to find out that the origin, or the point 0, 0, is going to be your x and y intercept. Now, one last thing. When you substitute 0 in, basically what you're doing is covering that up and solving that. Or covering that up and solving that. Covering up this and solving that equation there. And same thing here. And so some people teach it like that. Just cover up the one that has the variable and then solve what's left over. Okay, that's x and y intercepts.